On example 6, I would prefer to work this with a tree diagram. All of these problems can be with a tree or a Venn or a table or a formula, but this one I like to do a tree diagram on. We've got two office assistants, Rudy and Fawn. Rudy and Fawn. And it tells me Rudy gets the list 30% of the time and Fawn gets the list 70% of the time. Now, sometimes they don't get it there on time. So sometimes they're late, sometimes they're on time, late and on time. And so it says Rudy fails to get it there on time 10% of the time. So he's on time 90%. And Fawn succeeds 92% of the time, which means she fails 8% of the time, 0.08. Be careful there not to write 0.8. And so then you multiply down the branches. And so zero point 0.3 times 0.1 is 0.03, zero point 0.3 times 0.9 is 0.27. Those two things add up to the 0.3 that Rudy gets. And then Fawn is going to be 0.056 and 0.644. And those four numbers will add up to 100% or add up to 1. So the question says, what's the probability that if it's late, it came from Rudy? So that's written like this. What's the probability that it came from Rudy given that it's late? Now, which ones are late? Those two. So those two go on the bottom of this fraction. And of those two, which ones did Rudy do? He did the 0.03 on the top. So then you can stick that in your calculator and it gives you 0.349. So even though Rudy only works on 30% of the lists, if it's late, there's almost a 35% chance that it came from Rudy because Rudy's late percentage is a little bit more than Fawn's.